Thank you, everybody, for being here in person and online. My name is Jeff Sebo. I direct the NYU Center for Mind, Ethics, and Policy. And this is a special public event being held during the 2026 Mind, Ethics, and Policy Summit here at New York University. And we have a bunch of amazing researchers and practitioners from universities and companies and NGOs, and are having a really great series of conversations over a couple of days about animal welfare and AI welfare. And here to speak to both the in-person audience for the summit, but then also the online audience attending remotely, is our colleague and friend, Ned Block, and we are very, very honored and privileged to have him here with us. So I will just give a brief introduction, because only a brief introduction is needed. When you are a successful and accomplished academic, you have this kind of trajectory where the more accomplished you get, the more you start loading up your bio with all of your accomplishments, all of your books and your papers and awards and recognitions. And then you reach a certain point where you start pruning those things back out of your bio because it starts to feel kind of gauche to keep adding all that stuff in. And so this is Ned's current bio. Ned Block is Silver Professor of Philosophy at NYU, working in the philosophy of perception and the foundations of neuroscience and cognitive science. Before coming to NYU, he taught at MIT for 25 years. Ned, thank you very much for being here. We are looking forward to learning whether AI systems can be conscious if consciousness is biological. Ned will speak for the first portion, the first about half of the session. Following that, we will take questions both from the in-person audience and from the audience tuning in online. So if you are in person, think about what you might like to ask and be prepared to raise your hand. If you are tuning in online, just go ahead and enter questions or comments in the Q&A tab on Zoom at any time, and we can go back and forth. Okay, without further ado, thank you, Ned.
Thank you. Thank you, Jeff, and thanks so much for inviting me. It's a pleasure to be here. This talk is an update of an article I published last year in the journal Trends in Cognitive Sciences that is available for free on my website. And I think I uploaded it to Phil Papers, so it's probably there too. Okay, so this talk is about both AI and animals. Everybody will have read this paper, and in fact, Rob Long might be here somewhere. Yes, there he is. Okay, he's one of the authors. Okay, so this paper makes the assumption of computational functionalism, which it defines as implementing computations of a certain kind is necessary and sufficient for consciousness, so it is possible in principle for non-organic artificial systems to be conscious. So now I am going to raise some problems. I'm not arguing that computational functionalism is false, but rather that we have no idea whether or not it's true. And so this is an unjustified claim. Sorry, Rob. So note that the issue is whether biological mechanisms are necessary for consciousness, not whether they're sufficient. I mean, in some sense they've got to be sufficient. We have a brain, we know it's done in the brain, and that's enough to make you conscious. But then nobody knows really quite what the sufficient conditions are. So here is an important point, that even if consciousness has a necessary biological base in us, that might not apply to machines. So for example, reproduction has a necessary biological basis in us, the double helix and all that, but AIs might reproduce in some different way by making factories that make more AIs. However, importantly, if we did discover a biological basis for consciousness in us, it might be that our best bet for making conscious machines might be to apply what we have learned about us to them. Okay, I'm going to talk about functional roles and their realizers. So I'm going to assume that consciousness has a network of causes and effects amounting to functional roles in the brain and body. So here is a common sense functional role. You know, this is a problem. I don't really know what to do with it. This is, I guess, I don't need this for here, but this is for the people at home. Okay, so suppose, you know, there's a red light, it causes you to see red, and that causes you to think it's red, maybe it causes you to say it's red, and all these things together end up causing you to press the brake. But this is a just common sense functional role. There can also be a scientific or a more scientific functional role, which fits with a number of theories of consciousness, including the global workspace theory, which is that we have perceptual events in the back of the head, and consciousness is somehow involved in promoting them to the front of the head. Of course, the global workspace people think that the promotion is consciousness, but even if you think it isn't, even if you think that the consciousness causes that, in fact, I'm really assuming that it causes that. So the realizer of the role are the physical mechanisms that implement that role. Importantly, functional roles in this sense, which involve a network of causation, are broader than computational roles. Computational roles are a subset of this that involve computational processes intervening between these different states. So here is my sort of first important point, which is that if the role is what counts for consciousness, then all functionally similar beings are conscious. If the realizer is what counts, then we should be looking at animals. And without a theory of consciousness, we can't know whether it's the role or the realizer. And there is a tension here. You know, we have a large movement now to expand the moral circle, to use the title of Jeff's book, to animals. But that depends on realizers more than roles. The roles would suggest expanding the moral circle to include machines. And unless you think it's both rules and realizers, or there's enough of a probability of each, which is what many people are thinking. But, you know, if you're really looking for the essence of consciousness, it might be one, not the other. And so that creates a certain kind of a tension. Now here is the objection that probably everybody is thinking, that neuroscience and biology are computational. So the implementations and realizers will be computational too. So here is where I come to what I'm now calling analog processes. So a computational implementation of a rainstorm need not be wet. The computational implementation need not replicate the wetness properties. Similarly, a computational implementation of a neural process might not replicate the conscious properties of the process. It might describe or model the neural process without replicating all of the properties of it. A really good example from my point of view is gravity, especially Newtonian gravity. So, you know, Newtonian gravity says to compute the gravitational attraction of one body on another, you multiply the masses, multiply times the constant, divided by the distance squared. Now you could do that all day and never get any gravity, right? So, you know, it just makes it obvious that that implementing that computation does not produce the gravity of it. Now this doesn't show that for some processes, computations merely describe or model and don't constitute or replicate, but there may be other processes that they do replicate. So let's use the term analog. This is not the most common use of the term analog, but I think it has recently started to appear in neuroscience, and I'll say a little more about that later. We can say a mental process is analog if a computational implementation of it, not an analog implementation, but a more wide, a digital computation, need not preserve its mentality. More generally, we can say an X process is analog if a computational implementation of it need not preserve its Xness. So Newtonian gravity, that is gravity according to Newton's theory, is an analog process. Now it's an interesting question to ask, which processes are not analog? Well, pretty obviously, computing is not analog. So a computational implementation of computing is computing no matter how bizarre the implementation is. So I couldn't really find a really bizarre one on the web, but there's a mechanical Turing machine. But many people have suggested Turing machines that use toilet paper instead of the tape, with stones instead of ones and zeros. So that would be a really weird one. So what about dividing? Well, I think a similar point applies to dividing, a computational implementation of dividing divides. Reasoning, well, maybe it's a little more controversial, but I would suggest reasoning is another such case. And I would suggest that deciding is another such case. And maybe focusing attention is another one. What's common to these processes is they have what you might describe as a functional nature, a functional identity. What duplicates the functional role duplicates the process itself. But the problem is there's been a lot of discussion of whether consciousness is an analog process in this sense, under the heading of whether it has a functional identity. Here is an effort from me and Jerry Fodor in 1972. So this is an old topic, and I have to say it's long debated and never resolved. So we just don't know whether consciousness has a functional identity. That has an unknown truth value. And that's pretty important. It doesn't show that functionalism is false. It shows we don't know. And actually, it's worse than that because we don't really know how we'll find out. I think there are some promising things, and I believe that we have learned a lot about consciousness from neuroscience, and I think if we keep doing that, we'll learn more. So now we might ask, what about some other mental states like planning and having goals? But so here is Nick Shea and Steve Fleming in a reply, I think it's a reply to Neil Seth's article that's just about to come out in BBS, Behavioral and Brain Sciences. So they say having a genuine goal may furthermore require having genuine needs, perhaps even metabolism. If a capacity depends on consciousness, it inherits whatever substrate dependencies consciousness have. So that suggests that it may be that having goals and planning are either both substrate dependent or neither. So now, of course, many people will still say, if we can identify what the biological process is doing, we can find a non-biological way of doing it. But the question is whether that non-biological implementation will replicate the properties. So we have to distinguish between simulation and replicative implementation. Simulation duplicates the input-output of a process. Replicative implementation duplicates the input-output plus the intervening processing at some level of description. So this applies to the rainstorm example. A replicative implementation of a rainstorm at the right level would be wet. Now, Blake Richards and Blaise Aguirre E. Arcus said in the same BBS article, a perfect simulation of consciousness is consciousness, just as a perfect simulation of a calculator is a calculator. Note that they're talking about simulation rather than implementation. So the definition of computational functionalism describes implementation. Note that a simulation of an analog process can be digital, non-analog. So if your plan for life after death is to have the computations that characterize your mind uploaded into the cloud, I advise you to check that your mind is implemented in the cloud and not just simulated in the cloud, because simulation might not bring the consciousness with it. So, I've been talking about biological mechanisms. So what is biology anyway? So there's a lot to be said on this, and I've been doing some reading on it. And from what I've been reading, and with the help of ChatGPT, you could make silicon life. It would be unstable in the conditions in which we live, but it might be better in some circumstances, cold methane worlds or hot worlds. And there's a literature on this, exoplanet organisms. Let me move to the Church-Turing thesis. So I think I hear a lot of people saying things like this, giving an argument like this. The Church-Turing thesis says a function is mechanically computable only if it's Turing computable. The brain's outputs are mechanically computed, so the brain is computational, and computational functionalism is true. Now, Turing notes explicitly that the mechanical and mechanically computable is an ordinary term. It's not mathematically undefinable. And that's why it's the Church-Turing thesis instead of the Church-Turing theorem or something like that. So it decomposes into two parts. If it's Turing computable, it's mechanically computable, and the reverse. So on the first one, this is pretty obvious since the operations of a Turing machine are mechanical. String them together, that's mechanical. So it's mechanical. It's mechanically computable. Now the converse, that's the one that is most puzzling. One thing you could say is that no one can think of a convincing counterexample. Except that's not really true. There are lots of convincing counterexamples. Analog computers are one. Another is the Geiger counter. The Geiger counter computes, you can think of it as computing a function from, the idea is it taps a genuinely random process of radioactive decay. So you can think of it as computing a function from button presses on it to read radioactive decay to numbers. And people have discussed this, and I think what many people think, is that it isn't mechanical in the sense in which we meant mechanical. And this is, I think, a common response to counterexamples to the Church-Turing thesis. And it makes you think that there's really a very strong stipulative element to this. So I think the use it gets made of it in this context is not really very good. So what about the physical Church-Turing thesis? This is any function determined by a physical process. Well, this is very nicely discussed in an article by Jack Copeland in the Stanford Encyclopedia of Philosophy. And I won't quote this, but he says, he mentions this thesis, the Deutsch-Wolfram thesis, that says that every finite physical system can be simulated to any degree of accuracy by a universal Turing machine. And I won't read what he says about that, but it's an open question, is what the upshot is. And anyway, that's simulation, not implementation. So what I think is that exactly computing the function, implementing it, not stimulating it, can be expected to involve properties that are not present in a device that approximately simulates it. Let me just say a little bit. I've condensed an hour talk into a 35-minute talk, so I'm sorry if I'm sort of skipping around. I just want to make this point that the question of whether consciousness has a function is not the same as functionalism. This is a confusion often made. So, for example, perhaps a function of consciousness is motivation or promoting cognitive access, as I mentioned before. But it could have this function only because of an analog implementation. So consciousness having a function does not entail functionalism because that function maybe could be done in a zombie. The best I could do with a picture of zombies. So there's a kind of, here's a sort of decision tree. Does consciousness have one or more functional roles? So I'm assuming the answer is not no, because why would we have it if it has no functional role? If yes, is it multiply implementable? If yes, and if only the biological implementation is conscious, then functionalism is false and biology is necessary. If the answer is no, then functionalism still may be true, depending on what the nature of these other things are. But even if the answer is no, biology might be required, even if functionalism is true, because it might be that although it isn't the biology that makes something conscious, biology might be the only way to make a conscious thing. And that could still be a form of functionalism. It could be true. So suppose functionalism is true, the essence of consciousness is its functional role. Well, that's what I just said. Still, the only way to build it might be by some kind of biology. I won't go on with this. Okay, computation versus sub-computation. So the computational level, so an AND gate, a really simple computational device that is defined by this table. 2 ones make a 1 and everything else makes a 0. So note that 2 AND gates can be computationally equivalent without being the same in sub-computational property. Here's an electrical AND gate, a mechanical AND gate, a hydraulic AND gate. So these things are all different at the sub-computational level, but at the computational level they are all AND gates. So the sub-computational properties are irrelevant to its being an AND gate. So the relevance of this is, despite confident assertions of computational functionalism, the most basic fact is we don't know whether consciousness is computational or sub-computational, to put it in those terms. It's the same point, pretty much the same point as I was making before. Now, one of the articles coming out in this set thing is by Mathias Michel, who I greatly admire, but he has some very weak, what I consider very weak arguments for computational functionalism in that article. And he says, for example, for better or worse, computational functionalism is a view in metaphysics. The relevant kind of necessity is metaphysical necessity. Such arguments do not establish the metaphysical necessity of biology, and thus are harmless against computational functionalism. So I consider this a straw man. It doesn't say, it's true that Seth does argue against computational functionalism, but there is this weaker, what might be called an anti-functionalist view, which is the one I'm arguing for, which is we just simply don't know whether computational functionalism is true. He goes on to say, I'm about to argue that functionalism should be the default view and that there is currently no alternative to functionalism. That means no reason to believe that biology is necessary for consciousness. So again, I'm not arguing that. But again, I'm arguing for this weaker view. So the argument he gives is functionalism wins on induction. When we explain other psychological capacities, mental arithmetic, language production, causal inference, memory retrieval, etc., we do it functionally, and I'm happy to agree with that. We appeal to computations over mental representations, not special biological properties. Mental kinds are individuated by functional, not by properties of the neurological kinds that realize them. That is, we should expect that differences in mental kinds are functional differences, though through and through, including the differences between conscious and unconscious states. Of course, consciousness might be the exception. The thing is, everybody knows that these are all non-conscious cognitive, or can be non-conscious cognitive capacities. It's just ridiculous to argue from a functional account of non-conscious capacities that consciousness has to be functional. So induction doesn't tell us that a framework that applies to mental arithmetic, etc., also applies to conscious perception, conscious emotion, conscious pain, conscious bodily sensations. So that's a very weak argument. It's like arguing that the principles that explain events on Earth also apply to events in the cosmos. So, moving right along, if biological basis is necessary for consciousness, we might ask why and what aspect. So, why? Well, I have no idea. So there are many guesses about what aspect. So large-scale oscillatory signals that Peter Godfrey-Smith has advocated. Waves across the cortex, which are tightly associated with that. Earl Miller has argued. And then there's a lot of other things that other people have argued for. Seth has argued for autopoiesis, homeostasis, predictive processing. And honestly, I think these are all computationally susceptible in my view. I don't think these are very powerful ideas. Somebody who's been advocating something that might be called an analog process, and never just says what he means by analog, is Earl Miller. And here's what he says. He says, he's talking about waves in the cortex. The rotating waves act like herders that steer the cortex back to the correct computational path. The brain is using these traveling waves to actually do computation, analog computation. Analog computation is way more energy efficient than digital, and biology favors energy efficient solutions. It's a different and more natural way to think about neural computation. So this, I won't read this, and I'm going to skip Seth. Let's see. In a longer version of this talk, I go through all these theories of consciousness. These are the main ones from my point of view, and except for the biological theory, the others I think are all, in some reasonable sense, functional. I was interested in the fact that, so I mentioned I published this article in Ticks last year, arguing for a biological point of view. And one of the views that I criticized was the global workspace view. And just this month, or this week, maybe last week, I guess, I got an article that is either come out in Ticks or is coming out in Ticks by Jean-Pierre Changeux, in which he argues that the global workspace has always been a biological theory, and that they never thought that that it was implementable on a digital computer or anything like that. Now that's Changeux, who's a famous neuroscientist. I have my doubts whether Dehaan would agree with that, but in any case, there is room for a biological version of those theories, certainly. Let me move, since I don't have much time, let me move on to some very speculative remarks, starting with evolution. So, a candidate for the first animal, in the sense of metazoa, is comb jellies or ctenophores. Is ctenophore the right pronunciation? And an interesting fact that has emerged is that the ctenophore has purely electrical synapses, except at the input and output transducers. Now, interestingly, electrical synapses seem to have been, in a sense, a evolutionary dead end in this following sense, which is that we have early on in the, maybe not first, but the first two animals are either ctenophores, comb jellies, or sponges. Comb jellies have neuron synapses, muscles, and a gut, okay? Sponges don't have any of those, and placozoa have none of those. The next step up are cnidaria, like the sea anemone, for example, coral. And they have neuron synapses, muscles, and guts, and of course we do too. But what you see is, as soon as you got animals with electrochemical neurons, then they proliferated and formed sophisticated ones. And there's some sophisticated cnidaria too, the box jellyfish, for example. So it looks like there's a reasonable sense in which the ctenophores are a dead end with their purely electrical nervous systems. And that suggests that there is some important benefit to electrochemical nervous systems in which neurotransmitters, chemicals flow from one neuron to another in this chemical soup that surrounds all the neurons in your brain. So they flow, and the gates open, electrical signal slows down the axon, and then neurotransmitters are released again. So it's chemical to electrical to chemical to electrical to chemical. That's the way our brain works. So when I first looked at this, I was thinking that the electrochemical stuff itself may be what's important. But influenced by Peter, I have come to think that actually it might be oscillatory behavior and wave activity that are for which the electrochemical mechanisms are very important. And this actually gives rise to another interesting question as to whether there might be a difference between vertebrates and invertebrates. So I have only recently found out that there is a major difference between vertebrates and most invertebrates, not all invertebrates. So the octopus might be an exception. And that is, when I found this out, it was a kind of mind-opening thing for me, and I found out that a lot of other people had already known this. But anyway, the point is this. This is a pathetic figure that's supposed to illustrate this fact. From a paper by R. Douglas Fields. And that's where I first read about this, and then I read a bunch of other things to explain it. So he points out that the vertebrate axons have thousands of connections to other neurons. Every single vertebrate, but typically the vertebrate axon has so many connections that the neuron firing cannot make another neuron fire. It has to be populations of neurons, and they're organized by wave actions, partly driven by ionic fluctuation in the soup between neurons in glial cells, and importantly, sub-threshold neural activity. So, what I'm now thinking is that this may be analog process and important. And here is I've put Peter in there because he's been advocating something like this view for a while, and I've been resisting it. But here is a quote from Fields. The enigma of how sparse, weak synaptic connectivity can drive postsynaptic neurons to the action potential firing threshold erupts from a clash between the reality of neural network connectivity in human cerebral cortex and the simplified, oversimplified conceptualization of neural transmission and integration that is overly focused on action potentials, that is, neurons firing. The mistake, he argues, and I think he's right about this, is to focus on neurons firing as if they're elements in some kind of digital device. An essential aspect of neuronal integration is the subthreshold oscillations in neuronal membrane potential that are seen in neurons of all types. Subthreshold oscillations in neuronal cell bodies, dendrites, and axons will interact with oscillating extracellular field potentials. That's in the soup between neurons, recruiting individual neurons into functional cohorts. So I think this is a new point to me, and I think it's interesting that I think in neuroscience now, a lot of people are coming to think maybe this is important. I think many neuroscientists were neglecting dynamic systems theory, and I've talked to a dynamic systems theorist about this, and I think it's now becoming more popular anyway to take these sort of ideas seriously. So let me conclude, and I'm concluding on time. Is a biological basis required for consciousness? Maybe. And that's it.
Thank you so much, Ned. And we have plenty of time for questions from the audience both here and online. I see Rob throwing his hand up, so how about you go first?
Great. Yeah, thanks, Ned.
Hang on, Rob.
Oh.
So the online people can hear you.
Thanks, Ned. I did just want to say, for the record, that maybe is also the position of the consciousness and AI paper. It says that that's a working hypothesis, but at various points we say things like, it could be that some non-computational feature of living systems is necessary for consciousness. So anyway,
Is it what?
that some is necessary for consciousness, in which case consciousness would be impossible in non-organic artificial systems. No, and then it says we have different levels of confidence in computational functionalism. So maybe, I guess, maybe some various strengths. But my question, I guess, is a bit related, but it's maybe taking you out of philosophy of mind and philosophy of neuroscience and asking you a Center for Mind Ethics and Policy kind of question. I'm curious what you think we should do while we're in this maybe situation, and while it seems like there maybe are not great lines of attack on the question of computational functionalism and biological necessitism and things like that. Like you had commander data in your in the slideshow, and I know you've written a paper about commander data. What do you think we should do with, say, commander data in the meantime? Something that's very cognitively similar, even more so than current AI systems.
Okay, fair enough. I maybe have been hiding. All right, so look, I'm not sure what maybe the upshot is, I mean, you and other people have pointed out that maybe all that's required for treating the entities as well for subjects is a reasonable probability, or maybe a reasonable probability wrong. So non-negligible probability. And then you have to pay at least some attention to the possibility. I guess I think that may apply both to AI and to animals. So, maybe the upshot of this is really the same as what you already thought.
That's my favorite kind of talk. Yeah.
Just a quick follow-up. I remember when we first released our paper, Taking AI Welfare Seriously, and Rob and I presented it for a reading group that you hold in the philosophy department. You asked this question of us and of me, that I advocate for consideration for animals and AI systems on the grounds, not that they definitely are conscious, but rather that there is a realistic possibility of consciousness. Yeah. And where you put pressure on me, and I heard this coming out in the talk too, is there might be a disjunction here, that the theories of consciousness that support, for example, invertebrate consciousness, might in some cases be different from the theories of consciousness that support AI consciousness. And so as we learn more, we might find we have to choose one or the other. But for right now, we might give some consideration to both of them as a kind of disjunction under uncertainty. And that is kind of my view, though I am worried about a future where we do make enough progress. Well, maybe I should welcome a future where we make enough progress that we can confidently rule out one or the other.
Well, if you're very committed to both, maybe you should make sure to undermine science.
Well, I am committed to both if there is a possibility. If we learn that there is not, then I would not be. But yeah, it would be sad to say goodbye to one of my main two constituencies in the Center of Mind Ethics and Policy. One more question from in person, and then we can go to an online question. Peter.
One kind of skeptic about the last part of your talk might say that it could be true that the way to make a brain work well and do all the things that it does is to have that combination of oscillatory large-scale stuff with the firings of individual neurons and so on. And brains just wouldn't work well if they didn't have that combination with the electrochemical basis for those things. But is there something about that collection of features that has a link to consciousness itself that makes it look like a kind of explainer for you, such that, if we started again and looked at consciousness and then wondered, what kind of brain activity would be a natural explainer of the kind of consciousness we find in ourselves? Do you have a piece of the story like that in place at the moment?
No, I don't. Look, I believe in what Dave calls the hard problem of consciousness. And I think, I believe that we have made some little time, as I said at Columbia yesterday, we've made little tiny shreds of progress in that regard. I'll mention the case I mentioned yesterday, which is that my colleague Marissa Carrasco in the psych department at NYU has explained why it is that when you attend to something, it looks slightly larger. And the explanation is, well, the main part of the explanation is when you attend to something, you are focusing more brain real estate on it. The so-called, so there's perception scientists have this term receptive field, which is, the receptive field of a neuron is the part of space that it processes from. And what she's shown is that neurons, if you are attending to this little thing here, the neurons that are trained on that, when you attend, neurons near them alter their receptive fields to move so they pick this thing up. So there's simply more neurons that are trained on it. And there's a couple of additional features, which is, there's something called the labeled line hypothesis, which is that there's some kind of correspondence between positions in the visual cortex and positions in the world. There's kind of equivocal support for this, but that also would indicate this. So maybe it's a combination of those two ideas. So that, to me, there's a question, why do we have this particular experiential phenomena? And it's getting something of an answer from psychology and neuroscience. So I feel like we can make a little bit of progress towards, not solving the hard problem, but just a little, just chipping away at it. I guess that's the right word, chipping it away at it. And I'm not confident that any of these, like wave theories or anything like that, are really just going to automatically solve the hard problem. I think we've got to do this chipping away at it and hope for a really good idea.
And you don't think that explaining unity and binding and those sorts of phenomena is a kind of little piece of a bridge between the two? Because some oscillation people think that is a kind of bridge between the experiential side and the...
Well, binding is, I think, like the attention point. It's a perceptual phenomenon that, affects how things look. We see the color and the shape and the motion all together, bound together in one item. And so to the extent that we can explain that, we're explaining a feature of the way things work. I'm a bit of a skeptic about unity of consciousness. I think we'll all have to watch out for the philosopher's unity where, oh yeah, when I'm thinking about unity in my study, I get that unity. I'm pretty disunified myself. So I don't really, I see binding as a chipping away. If we can explain unity to the extent that we have it, I could see that as chipping away too. I don't see it as, somehow solving the hard problem.
Thank you. So we have a lot of questions coming in online. Several people are asking about the same theme, so I can pose a question that brings those ones together. Under what circumstances does it make sense and not make sense to assume computational functionalism when doing science and philosophy of consciousness? For example, it might be premature to assume it as in this is the truth and we can proceed from here, but it might be reasonable to assume it as a working hypothesis for the sake of exploring the space of possibilities and figuring out what would follow if it were true. Somebody also asked, what do you make of the work happening in Anthropic right now and the work starting to happen in general in the AI space? Is there a way of doing this responsibly given the current state of uncertainty? One of the questioners called out Kyle Fish from Anthropic, which is great because we have him just over there in the tables. And so, if you can speak to when can we assume it and for what purposes, that would, I think, be helpful for some of the online folks.
Yeah. So look, of course, something that you don't know to be true, or you have no reason to believe to be true, can be assumed in the antecedent of a conditional. it's worth exploring. If it were true, then blah, 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 what would we do? Stuff like that. There is the danger of a working hypothesis becoming your hypothesis. That antecedent taking over. And I think that's what happened in Rob's paper. You can express a little bit of we're just a working hypothesis. But then that is no longer working hypothesis anymore, it's just a hypothesis. So I'm very wary about that.
Great. Another question? Another question from the room? Yeah.
Thanks. Yeah, thanks for the talk. I guess one sort of theoretical question and one sort of vibes question. The theoretical question is there any theoretical experiment that you could stipulate that would move you from, or for which the results of that experiment would move you from the maybe to the yes? Can you even come up with something, or is it just in theory there's nothing that's going to move you off of maybe? And then the only other question I have is, I maybe didn't catch the...
Can I go for that first?
Yeah, please go.
Okay, I think you left out a possibility. It's like either I can think of an experiment or I have theoretical reason for thinking there couldn't be one. I don't believe either of those. I have something in the middle, which is that it's chipping away at the problem that gives rise to new hypotheses that make some progress in telling how we would tell. So, I'm a very old person, and I've been around, I remember way back when the world of consciousness had no serious research, and people couldn't even agree as to whether it was a verbal thing, or that is, it required the use of language. And there are some people who still think that, I think. And so look, I think we've made, it's not like we know that there's a true theory, but I think we've made enormous progress in studying consciousness. And as you make progress in your theorizing in tandem with making progress in your understanding of what experiments would lead to what. So, moderately optimistic that we're going in the right direction here, but I don't have any experiment in mind that would really do it.
That makes sense. Should I do the poll? Okay. So I guess just one thing, I was with you for most of the talk. Towards the end of it, I felt like I would have been more compelled by what you were saying if you were saying it 6 years ago or something. And this is again more like a vibe-based point, but I feel like to me the insane and sort of unpredicted success of the LLMs, let's just say, to me is a point that, as someone who's far more sympathetic to computational functionalism, I'm sort of I'm not as convinced that glial cells are where the magic is happening in brains, because we basically took some core abstraction of neocortex, threw a ton of compute at it, and now it's smarter than everybody in many key areas. And I use it for everything I do, and it makes my life way better. I'm not saying that is evidence of consciousness, that's the sort of vibes-based point that I'm trying to get at, but does this update you at all? You were saying you're talking to ChatGPT and it's helping you learn about all sorts of stuff. Is the remarkable and unpredicted success of these systems moving you in any direction about what other complex cognitive properties they may have, or is consciousness just categorically different for some reason?
Yeah, so look, I use ChatGPT every day and Claude as well, and I pay the $200 a month for the really expensive version, and I really find it incredibly useful. And I have to say, we had a AI discussion group in 2021 and 2022, and everybody in that group, including the computer scientists people, were blown away by what happened. Nobody predicted it. The cognitive abilities are incredibly impressive. However, there is a huge difference between cognition and consciousness. So the fact that we can make a device that's pretty simple in principle, that can do amazing cognition gives me zero confidence that it's conscious. These things are really quite different. You know, I think it's now 4 years ago, I published a book on the distinction between perception and cognition, which is a free download from Oxford University Press, and it's also on my website. And what I argued for was a strict separation between perception and cognition. And the points I made apply also to consciousness and cognition, which consciousness played a role, but you know, I was basically adopting the methodology of talk about perception, whether it's conscious or unconscious, to fix this processing point about perception and cognition being quite different kinds of things. Ooh. Yeah. Sorry, I need that to hear. I think what was really amazing to me was the extent to which pattern completion is really a humongous part of thought. And it's really incredible that they can do these amazing things. I have to say that there are important problems in the way the LLMs think. And, you know, I mean, it's the most obvious manifestation is difficulties with simple arithmetic. You know, I teach an undergraduate class that includes a lot of AI stuff. And last fall, I taught it last fall, and I gave ChatGPT, which of course was an old model by today's standards, a number of 4-digit multiplication problems couched in kind of disguised way in words. And you know, after about 5 of them, it got one wrong. And you know, GPT-3 famously couldn't, it was, as I recall, 20% correct or so on 3-digit multiplication. You know, there really is, you know, and another thing is, you know, people are constantly, if you follow people on Twitter, they're constantly posting crazy mistakes. Those crazy mistakes often are of the form, there is some rule-governed behavior where the rules are very well known and known to the LLM, but it still gets them wrong in an odd circumstance. One of them is somebody gave an LLM, this was I think also last fall, so maybe it doesn't apply to the current ones. Of course, you know, everybody in all these companies are busy reading these Twitter feeds too, so that, but what they showed was that for odd board configurations that don't come up much, ChatGPT was, or whatever AI it was, were making illegal chess moves. The one I remember is using a queen as if it was a knight and could jump over pieces. But you think, now what's going on here? I mean, you know, the rules of chess are in the machine. Why is it doing that? And the answer is, it's not using the rules, it's not applying the rules. And, you know, so many people have argued for so-called hybrid systems. But I think that, from what I understand, it's hard to make those really work. You know, as I understand it, I don't really, I'm not really completely up to date. A lot of the current AIs offload arithmetic problems to some other digital device. Anyway, this is all a long-winded way of saying I think the enormous, incredible successes, unanticipated successes in cognition do not tell us anything about consciousness.
Great, just a quick follow-up from me, and then I see we have a couple other hands here. So in the course of answering that question, you said that when LLMs or AI systems can perform these incredibly sophisticated cognitive tasks, that gives you zero confidence that they are conscious. I want to know how literally you were speaking in that moment. Basically, do you regard it as any evidence at all? Does it update you even a little bit about whether those AI systems are conscious? And the sort of underlying question, and this goes back to the very first question of what do we do under persistent uncertainty when we might not have a secure theory in the offing, is, okay, we have to proceed by figuring out what counts as evidence and how much weight to give that evidence. And a natural way of thinking about it is, okay, if computational functionalism may be true, and that was the conclusion of the talk, then we should give some credence to its truth, some credence to its falsity, and then conditional on its truth or falsity, we give weight to evidence that would follow from its truth or falsity. So if you give 50%, 0.5 credence to its truth, might be higher, might be lower, you can then weight evidence accordingly, but you would still count it as evidence. So I wonder if you see the evidential situation differently, or if you are just that skeptical about computational functionalism as a hypothesis.
Yeah, look, I guess I am going to take a pass on that question. I should think about it more. I have to say I have a strong inclination to say 0, but I feel I haven't really thought it through.
Fair enough. Here you go.
I have a question about academic integrity and authenticity. I was wondering your thoughts about, as academics, where do you draw the line? What do you think should be our rules about how we use it in our academic work?
For AI, you mean?
Yes.
I don't really have much to say about this. I think it's a terrible problem in academia. In our graduate admissions this year, we're interviewing people because we don't know who wrote their writing samples. We get papers from students, and many people are moving towards in-class writing of papers. Look, I use it all the time. You'd have to be an idiot not to use it. You can stick a paper you're writing in there and get really nearly professional level critiques. Where they give you advice and tell you made mistakes, stuff like that. It isn't quite at the level of one of my actual NYU colleagues, but it's really pretty amazing. And there are lots of misunderstandings and stuff like that. I somehow have the feeling that if I were to put a lot more text into the context window, I would eliminate some of those misunderstandings. So, of course, we all know that the cost of what I'm doing is way more than I'm paying, and that maintaining thousands of pages in the context window is very expensive. So, I don't know what the future will bring. When there's an AI, there's too many. Everybody thinks there's too many AI companies to make enough money, and there'll be a shakeout and all that, and they're going to start charging more or something, and then only rich people will be able to get the AIs to write their journal articles. But it's a huge problem, and I think we all need to be thinking about it. And so far, I read stuff on it, and I haven't really seen much in the way of words of wisdom. What do you think?
It's crazy powerful. I think it's inevitable. My students are going to use it in their real life, and so as a teacher, I have to figure out a way to have them use it and it still represent their authentic self and have it be their work. To me, that's the problem. Is like, and also in my own writing. Last night I was working on something, and I said I didn't say that. I was with Claude and kind of produced this thing. I said, take all of that out because that's not me. That wasn't my research. I struggle with it all the time. I don't have any good answers either. But I think it's an important question for us going forward.
I have to say that the use that I find the most important for me is explaining difficult technical material. I read a lot of science that I don't understand. And God, you dump the paper in there and say, explain it at a high school level, explain it at a 12-year-old level. And then you can start asking questions and it explains that beautifully.
I tell my students, use AI, plug my syllabus in, plug my reading in, plug my question in, put your class notes in, and that's your first draft.
Other questions?
Yeah, thank you. Wonderful talk. I'm really curious about this distinction between simulation and implementation, because it seems like a lot hinges on that, right? If it turns out that everything is implementable, then we might be good with computational functionalism. And so I'm curious if there's any first pass at a principle that defines what sort of processes are going to be implementable via computers and computation, and which ones are only going to be simulatable.
No, I don't really have anything general to say. I should remind you that, of course, LLMs are all simulating neural networks. They're not implementing them because they all run on NVIDIA chips. So yeah, but that's a really important general question. I'll ask ChatGPT.
So, thank you. So this is really just a clarification question. I think I failed to understand what an analog process is.
Yeah.
So in the case of gravity, we have it that, we can write down the equations. We can approximate them with Newtonian physics, and write them down, and we observe some stone falling down, and that's gravity being implemented. Now what you're saying is, well, we could have done the calculation of what is going to happen to that stone, and that is in some way a computational implementation, but insofar as those two things are not the same, we see that in this case gravity is an analog process. But that didn't quite click with me, and I wonder if you can just give more examples of analog processes.
Okay, so the way I define analog, which may not be the way you're familiar with, I have used analog in a different way in earlier publications. The way I'm defining analog is an analog, a mental process, a process in a machine is, there's a narrower definition in terms of mental. It's analog if a computational process is analog if an implementation of it does not preserve the mental properties. And in general, an X process is analog if a computational implementation does not preserve the X properties. So gravity is an analog process in my sense because you can implement those calculations. That is, you can do those calculations and get no gravity. So that's what I meant.
Could you give another example?
I think, it's harder to, I think the more difficult question is to find processes that aren't analog. I picked computation, arithmetic, reasoning, deciding, but your garden variety physical process is analog. Just name a physical process, they will be like gravity.
Some people online have strong reactions about your takes on AI in particular, not necessarily consciousness, just the capabilities of AI. One person said, "Is this a ChatGPT commercial?" And another person said, "These are such outdated takes about the capabilities of AI. Have you not heard of Mythos and other new front models?" So people are debating whether you are not being credulous enough or whether you're being too credulous about AI. What do you think about this?
Well, I would like to see it, Mythos. Of course, there's a myth of growing because not very many people have actually laid hands on it. No, Rob's seen it. What do you think, Rob? Give us a hint.
Well, it's really good at talking about consciousness, I'll tell you that much.
Other questions? Yes.
Hi. It sounded towards the end of your talk like you were talking about this oscillatory view in which there are these waves of potential unfired neurons as though it would undermine a computational functionalist view. Now, I don't have a background in computer science, and I have a very limited background in the sort of substrate dependence literature. So I'm not sure that I understood that move. Why is it that these sorts of oscillations and potentials are in principle not computable?
Okay, so you didn't miss anything. I didn't really give an argument. So I'm just relying on a kind of intuition that when you have these, fluctuating electromagnetic fields and subthreshold activity in fluctuating ionic processes, subthreshold ionic process in a neuron, and in the soup, it just seems kind of like an analog process to me, but I don't really know enough about it to be sure.
Yes, I was a little.
Hold on.
When you asked about cognition and consciousness and disentangling them, results from AI, and what kind of things it can solve, how successful it starts becoming, I was a bit confused because you suggested that you might have zero credence given its.
Wait, no, what, I didn't hear that. What? Could you move the microphone closer?
Oh, okay.
Yeah.
Oh, is that sorry? So I'll repeat the question. So basically, you said that you disentangle basically cognition from consciousness, right, in strong ways such that you wouldn't think that any cognitive results from artificial intelligence would suggest you or increase your credence strongly enough. So what confuses me here is so let's say that an AI brought a paradigm shift, right? Under that situation, if we keep saying no and no and no as these AIs become smarter and smarter, it seems like we're going towards the more we disentangle, the more we're going towards an epiphenomenal conclusion, right? So what's left for the AI then? Or so what role is left for consciousness if we keep saying this cognitive task is not sufficient, this one's not sufficient, right? So if nothing increases our credence, I do think we're stuck in that conclusion, right?
Well, I would not conclude from consciousness isn't cognitive to consciousness is epiphenomenal. Look, it's true that skepticism can lead to more skepticism. I guess maybe that's what you have in mind. But look, I think we're making progress on consciousness, and so I'm not worried about the fact that there doesn't seem to be a close enough connection between cognition and consciousness. And the progress is, I think, largely in the science of perception.
Thank you. So this is following up a bit on Peter's point. I guess I'm wondering to what degree sort of this biological hypothesis is mutually exclusive with some of the main theories of consciousness that you were talking about. Because I could imagine a view in which you say that, look, merely having these oscillations, for example, or if it's some other biological process, is potentially necessary but insufficient to create conscious processes. It might be that there's some additional function that needs to be implemented, and there's an evolutionary story of what consciousness does. Maybe it's some kind of world modeling or something. And in principle, you could have a high level, analog or isomorphism of that functional process implemented in silicon-based substrates or in machines. But then it wouldn't be conscious because it's lacking these cellular oscillations or something. So I guess I wanted to ask, to what degree do you think that your view is consistent with and potentially also codependent with some further explanation that gives some functional characterization? Or do you think that basically if we're not going to need something like that to get something more explanatory?
Well, I don't feel like I'm ruling out some important functional component. I'm just, cautioning against assuming a functionalist theory. So, and I mentioned that this work on, I think it's called exo-organisms or something, that suggests that maybe there could be silicon biology. So, maybe I haven't really got the point.
Yeah, sorry, I guess I just meant, maybe you want to be a global workspace theorist, but only for animals, say. So if you try to mimic a global workspace in a machine, you wouldn't make something conscious. But you also still need something like, say, a global workspace to make animals conscious. would that sort of view, where you combine a biological sort of necessity view with a particular theory of consciousness, for instance, global workspace, would that be something that you would be amenable to?
Yeah, I actually said that in the very beginning. That, we might find the basis of consciousness in animals, but then there will be some other basis that AI could have. So I'm not ruling that out. What I suggested was that it might be the best, if we did really find the biological basis of consciousness, I don't think it's a global workspace, but if we really did find it, that might be the way to make a conscious AI.
Some other questioners wonder if you saw the fly that was simulated recently.
I've heard about it.
Yeah, and if this type of experiment, if this type of simulation might move you at all. For example, if you can recreate in virtual space the cognitive system of a biological entity at a certain level of fidelity, and then you discover that level of fidelity is sufficient to get all the same behaviors and all the same environmental situations, would that move you at all about whether consciousness is also realizable at that level of fidelity?
Well, that's an interesting question, not about the fly, but about something that I really thought might be conscious. I guess I would predict, but here's the thing. You simulate everything going on in the brain, and you don't know what, the question is, what are you simulating? Are you simulating both the consciousness and the cognition? So, yeah, so you simulate the whole brain and you get behavior like the original animal. I'm not sure what that would show. It shows that the brain is what does it. But we knew that already.
Well, I guess the idea is that the simulations would get more and more fine-grained over time. And it might not yet have perfectly recreated all of the tiny chemical and electrical signals and oscillations, but maybe somewhere along the way towards that, you have enough fidelity that you are getting one-to-one behavior. And would that change anything about it? Yeah.
I very strongly doubt that just by simulating neurons, you're going to get the behavior of the original animal. So I haven't seen the paper on this fly thing, but certainly for vertebrates, the points I made about wave action, I don't think you would get the same behavior without the wave action.
So this is an empirical hypothesis. If you did get the behavior, that would maybe move you.
Well, that would show the wave action was phenomenal, or maybe it would show that by simulating the neurons, you're also simulating the wave action. I'd be very puzzled by that.
Yeah. Okay, great. We have time for one more question.
So this has been somewhat covered, and maybe you sufficiently handled it at the end, but maybe clarify that. So I feel like a really important thing here is whether analog processes exist at all. So you give this example with gravity and with wetness. And so I feel like there's a little bit of a sleight of hand, which I thought was kind of glaring in the beginning, but maybe again is resolved. When you say something like a simulated thunderstorm wouldn't be wet, wet to me is a description of a perception, which means there has to be an entity perceiving it. So in that simulation, if there is no perceiver, then there couldn't possibly be wetness. So you're not doing a fair comparison. So you'd have to create. So I feel like there's a paucity of computation, kind of in that comparison. And I think for people who are computation inclined, I'm confused of where I'm at. But I would want like a really robust computational simulation. And then, so yeah, if you had entities in there that could perceive wetness, then the storm would need to be wet for it to be a thunderstorm by my definition. And same with gravity, I guess, that I don't know what's being shown. I mean, it's a fast talk, and so I'll wrap up with this. So with gravity, in the real world, I guess, is you have a multi-entity, kind of chaotic system. It turns out there's a simple mathematical equation for point gravitational effects, and you can write that down. But that writing it down, I guess, it isn't gravity. So to me, again, for there to be gravity, there have to be entities upon which gravitational force could be experienced, etc. And yeah, if you showed all of that, similar to the wetness, then it would need to be the case that these objects would move, say, in a three-dimensional system consistent with that equation, in which case I would say it starts to get less clear whether that gravity doesn't exist governed by that equation.
So it's important that when I defined analog, I was talking about an implementation, not a simulation. And it was for precisely the purpose behind your question, which is I wanted to avoid issues to do with a simulated world. So that's really my main point. My point, so an analog process, gravity is an analog process because you can implement the computations. You can actually do the computations without any gravity. I'm not talking about simulating the computations, I'm talking about actually computing. In the case of Newtonian gravity, it's just obvious. You can multiply and divide numbers and you don't get any gravity. So I would say there's another kind of aspect to it, which is that, I think there's a really important difference between the nature of something and how we know about it. And so your lead-in was that you assimilated wetness to our knowing about wetness. I think wetness can exist in a world with no perceivers, no people, no life at all. The world can have a surface, and the surface can be wet, even if there's no one there to see it. So I make a strong distinction between what it is for something to be wet and the knowledge of a conscious creature that the thing is wet. So I'm talking about what it is for the thing to be wet.
Okay, we are now at time, so let's all thank Ned Block again. Thank you, everybody who tuned in from remotely, and thanks especially to everybody who came here in person. I hope you all have a great rest of the night, and those who are here in person, let's have some drinks.